Okay, let's talk about sequential statements with conflict resolution. Or more specifically, let's talk about conflict resolution and what it means. And then we'll look at how we define or how we design a conflict resolution sequential statement. All right, so let's take a look at sequential statements with conflict and how we resolve them. Or more specifically, we're going to define how we build sequential statements with conflict resolution. But first, I think we should talk about what conflict is. All right, let's get into this. So essentially what's going on here is that this is some symbology here for stuff about conflict resolution. But let's talk about what conflict really is. So to do that, I need to define some terms. Okay, so we're going to talk about active and held active and define what an active action is. So as you guys have learned, the uppercase letters are for actions and the lowercase letters are for limit vowels. In this case, we can see that there are two actions. There's an A plus and an A minus. So essentially the A plus is the out action and the A minus is the retraction action. And we can see this. If I were to have this as a control statement, I know the last action in this control statement is for A to retract. Okay, I mean, it's really simple. This is actually a really simple sequential statement. And you can imagine the control statement, it's A plus, A minus. That's it. It's the simplest you can get. So in this case, let's talk about which one is active and which one's not active. In this case, what's going on is that A minus is actually active because it's the last action. So if you ask this control statement, okay, go. A extends and then A retracts. So which action is the one that's active? Now, what I mean by active is before we start everything. It's just sitting there. It's kind of like its normal state. Kind of like a normally closed switch is closed normally. So in this case, the active state is what we're talking about when it's just normal. It's just sitting there doing nothing. Okay, good. So we've defined that the active state here. So I've highlighted it in green. So we're gonna stay with that convention. So anywhere where we see a green indicates that that is the place. That's the active place in its normal state. Okay, good. So now we have a further sequential statement here, and I think you guys are good with this. And we can see that the last two actions are A minus and B minus, right? So those guys are active. Because, you know, A is retracted and B is retracted because they're both ready to extend. Because the first thing that happens is A extends, and then the next thing that happens is B extends. So they must be retracted if they're going to extend. There you go. So we've defined the two active states here. And let's continue on and talk about held active. This is where conflict really kind of sneaks in. But we don't have conflict yet, but we'll see it. Now hold on here. Just hold on to this thought. What's going on here is that we know that A is active for sure. It's retracted. Now B is also retracted, but guess what? It's held retracted. A is not held retracted. Let me ask you, if B is retracted, is air going through B plus? Well, no. B plus is the outside limit valve. If B is retracted, the outside limit valve hasn't been activated. It's not passing air. So therefore, there's no air that's actually telling A to retract. Actually, if you went over and grabbed onto A and tried to move it, it would move. You'd actually physically be able to pull it out because there's nothing telling it to retract. It's just sitting there. But B is being told to retract because the action that makes B retract is when A retracts, and A is retracted. So we know that all of these limit valves have air going to them. So therefore there's air going through A minus. It is passing air right now, and that's actually telling B to retract. So if I went over to pull B out, it wouldn't go. It's not going to move. It is retracted. So what we're saying is it's not only retracted, but it's held active. Yeah. So B is held active. So is that a problem? I mean, should it be a problem? Well, let's take a look at it. So we can see actually, there actually isn't a problem. And we'll see this in a second, but take a look at this. If we didn't actually press that button, if we didn't have that button there, that push button, then A would actually extend as soon as B retracted, which is pretty cool. It would actually start the cycle again. And then we can see that actually when A would actually be held active, but it would actually activate. See, the thing is, what we're highlighting here is the fact that the push button is so very important in this cycle. So the push button is going to stop A from extending. So A will not extend, but if I were to take this out, this cycle would go round and round and round and round, and there actually wouldn't be any conflict. It would be okay. Let's take a look at it. So if A did extend, what's going to happen is that when A extends, this guy is opening up because this will no longer have air passing through it. A will have passing through it, but it's the instant A extends just a little bit and it moves away from the inside limit valve, B minus is no longer held active. So in this case, we can see there is actually no conflict. Everything will work fine. If you press a button, it'll cycle. It'll keep cycling as long as you hold your finger down on the button. If you stop, it'll stop at B minus and it'll just be fine. And the fact is we don't have a conflict anymore, or more specifically, as soon as A starts to extend, B minus is active, but it's not held active. Now, let's take a look at a different sequential statement. We're going to see that's maybe a little bit different. This is AB, AB. Okay, let's take a look at what this says. AB, BA. Okay, in this case, we actually have conflict. Now, let's discover where the conflict is and take a look at it. Okay, so if you were to try and press play here, if you press the button, wouldn't happen. Nothing would happen. The reason is because the last action is A minus, and it's an active action, and it's held. Yeah, so B minus is held. I mean, B minus is active, but it's not held, and that's not a problem. But in this case, because B minus is held, there's air going through here, and it's telling A to retract. Now, as soon as I press this button, A cannot extend. The reason A can't extend is because B is retracted. What? Yeah, take a look at this. I cannot make A extend because B is retracted. B is active. B minus is active. It's not being held, but it's active. That means that there's air coming. So as long as B is retracted, it's telling A to extend. So it can't. Retract. As long as B is retracted, it's telling A to retract. So if B is retracted and my first action is, hey, A, extend, it can't. Nothing's going to happen. When you press play over here, when you press that button, nothing's going to happen. Not going to go. So that's a problem. Yeah, what do? Well, we have this conflict, and conflict is there. Let's actually take a look at the conflict and the kind of the hosing of the conflict. So red line coming out of limit valve B minus is retracting cylinder A. So here we take a look at this. So B is retracted. So therefore there's air coming out of here and it's going in and it's telling this guy to retract this cylinder. So if I go ahead and I press this button, I'm going to tell it to extend, and the pilot pressure on this side is exactly the same as the pilot pressure on this side. So what's going to happen is that it won't win. It's not strong enough to battle this pressure to actually move the spool to make this happen. So there's kind of a fight going on here, and that spool inside is not physically going to move. And so this valve is not going to tell the cylinder to extend. It's just nothing's going to happen. It's too late. It's kind of like this got there first. Move the spool in the valve, and then the cylinder retracted. And then when I try and put air back in, it goes, oh no, I can't move because there's air telling me to retract. So that's what's going on. So you may think of a possibility like right here, how to deal with this, how to actually like make this go away. But let's continue to take a look at a little bit about how we identify conflict. And I want to find out how to actually solve it. Right now, I just want to identify conflict. There's some rules for identifying conflict. So there are two ways that we can define how we can see conflict out of these control statements. And one is if there's less than a quarter the number of actions between opposite actions. Okay, that's no problem. Let's move on. So, and then, what? No, what does that mean? What am I talking about? Well, I think we're okay with what opposite actions are. So A plus, A minus, B plus, B minus, those are opposite actions. So the quarter number of actions are, what's the quarter? Like, what does a quarter mean? Well, a quarter is you add up all of the letters. So if you add up all of the letters, those are the number of letters, and the actions in those letters are also the actual letters as well. But we have to define what an action is a little bit differently. Now, just bear with me. In this case, I've got a C plus and a C minus. There are two actions in between, and there are 6 letters altogether. So 2 of these is greater than a quarter. Okay, good. So there's no conflict here, right? So this B and this C, so 2 out of 6. So it's greater than a quarter. So there's no conflict. Let's take a look at this. Now, the wraparound concept, just wrap your head around that. So what's going on is that A plus happens immediately. As long as I have my finger on the button still, A plus is going to happen right after B plus. So this is just kind of a continuing loop that goes around. So you can count and go around and count and go around and count and go around. So what happens is B plus happens, and then A plus happens, and then B minus happens. And we can see that we have 6 letters here, a quarter of these letters. One of them is less than a quarter. And I've got one action in between B plus and A plus. Sorry, B plus and B minus, there's only one action. So there's conflict because that's less than a quarter. Now, there's another rule. It's the second rule. If the brackets, if whatever's in the brackets is greater than a quarter of all of the actions, there's conflict. And the reason is actually, it all boils down to rule number 1. It boils down to rule number 1. So you can look at it 2 ways. If there are enough, if there are enough letters inside a bracket that is greater than a quarter of all of the letters, it's a problem. So let's take a look at this. And the reason is because it boils down to the first rule. And the reason the first rule is this. Watch this. This is an action. This happens together. It is one action. So if we take a look at this, I've got C plus, and then I've got one action, and then I've got C minus. Now there are 6 letters here. So 1 out of 6 is less than a quarter, so there's a conflict. So what's going on is that because this is one action, there's one action between C plus and C minus, so there's a conflict. You can also just say, hey, if there are brackets of more than a quarter, then there's conflict. In this case, I've only got 6 of these, and there are 2 in a bracket, and that's greater than a quarter, so there's conflict. Over here, same thing, greater than a quarter, there's conflict here. And again, if we want to look at it, the conflict is actually, going back to rule number 1, between C plus and C minus, in that there's only one action between C plus. Sorry, I totally just lied to you. The actions between C minus and C plus. So there's only one action between C minus and C plus, and that means that there's conflict. But also we can say that those brackets, inside those brackets, there are 2 letters inside the brackets, and there are only 6 letters altogether, and that's greater than a quarter, so there's conflict. Now, there's no conflict here in this one. It's pretty cool. Take a look at it. So I've got all of this. At no point are there 2 letters in between. Are there more than 2 actions in between, or less than a quarter actions in between? So if I take a look at this D plus and this D minus, I've got 1, 2, I've got 2 actions. Okay, and they're all together, there are 4. There are 4 letters, so that's just on. That's a quarter. It's not less than a quarter. It is a quarter, so there's no conflict here. Again, even if I looked at C plus and C minus, so in between C minus and C plus, there's 1 action and 2 actions, so that's a quarter. Okay, let's take a look at this one. Now, why is there conflict between D plus and D minus? What's up with this? Well, because there's actually only 1 action in between them. Now, there are 8 letters here. But this is 1 action together. And those 2 in between here, this 1 action is actually less than a quarter, because out of 6 letters, 1 of those actions is less than a quarter. Hope that makes sense. Here, there's no conflict. Okay, so we've defined conflict. It all boils down to rule number 1, but you can easily do it with rule number 2 if you see a lot of brackets. So let's talk about how to solve conflict. What about it? Actually, let me just go back up here. How did you think about a way to solve the conflict in here? You might have seen something, but it's kind of not practical. Let's take a look at this. One of the ways is we can get rid of the air that's making the conflict in the first place. I can just reach over and kill the air. Now, we saw in this guy over here, this was our first original one that we looked at with the conflict resolution. We know that A cannot extend because B is retracted. So B minus is an active action. It's retracted, and it's telling A to extend. So as long as telling A to retract, as long as B is retracted, A cannot extend. So why don't I just go over and reach over to the valve, reach over to the system, and just kill this air. So I can actually just kill this air. So there's no air going in here. So therefore there's no more air going into here. So this guy is no longer held active. He's active. But remember, if it's active, I can just pull it and push it around. Held active means I can't pull it and push it around. So in this case, yeah, it's not a problem. But I can't run over and change it all the time. So what do? Is there some way that I can automatically turn the air on and off? Yeah, it's called a relay valve. It's a really cool thing. We'll get into that in a second. But let's take a look at the air supply here. Let me describe what's happening here. So if I can remove the air to B minus, okay, B minus is over here. So this air, if I could just remove this air, there wouldn't be any air going in here, and it wouldn't be telling A to retract. So the way I do that is actually I can use a 5-port 2-position valve as a relay valve to turn it on and off. Yeah, I can actually turn the air off here. Take a look at this. Okay, this is a relay valve. It's just a DCV. It's just a DCV, but it's a 5-2 valve. A 5-2 valve can be used as a DCV or a relay valve. So we're using it as a relay valve. Okay, good. So let's take a look at this. If I can turn the air off, okay, this B minus, the problem, here we go, B minus. If I can shut that off, that'd be really nice. So if I could just have air coming out of here and decide not to have it coming out, then air wouldn't be going into here, it wouldn't be going out of here, and it wouldn't be going into here and creating a conflict. So how do I use a relay valve to do that? Well, let's get into that a little bit further. Now, the problem was that the cylinder A was locked, okay? So it was locked, retracted. And what's going on is that when we put this guy in, we get rid of it. So now this is what's happening here as far as relay valves. Relay valves are just 5-2 valves, and we know that they're activated by pilots. You know that. Okay, well, let's take a look at this. So limit valve A minus, because limit valve A minus does activate. Here we go. Limit valve A minus goes down here, and it activates the relay valve. What that means is it changes the spool in here. So as soon as A retracts, right? Let's take a look at this. Okay, so what's going to happen is that this guy, A, is being told to retract. So the last action is for A to retract. Watch this. As soon as A retracts, what it does is it changes the spool in the relay valve. So therefore, what's happening is that air is going to come out here. When I change the spool, when I activate this, we know air comes from here and it comes out here. Now, the air is going to come out here and it's going to go and do its thing. But also, the more important part is that when I activate this pilot, air no longer comes out of here. Isn't that brilliant? It's brilliant. As soon as I activate this pilot, air stops coming out of here. So therefore, there's no more air going here, and there's no more air going here, and there's no more air going into here, creating the conflict. And I've shut it off. So cool. So this is how we define what that looks like in a sequential statement. So what's happening is here, this is the symbol for a relay valve. It's actually only half the symbol for a relay valve, but I'll talk about that in the next slide. So that's exactly what's going on here. And this is your first group. This is your first look at groups. So what's going on here is that we're going to split the control statement into 2 halves. We're going to say, okay, we're going to divide it into 2. We can also divide it into 4 if we wanted, but we're going to divide it into 2. So if we divide it into 2, what we're doing is we're essentially turning off the one half or the one group that's actually causing conflict. And then the conflict isn't there anymore. So therefore, the first half can go ahead. Now, we knew that there was conflict over here. This guy was retracted and this guy would not extend because it was told to retract. Now, watch this. This is the symbol for the relay valve. Here's the relay valve over here. We know that air from B minus comes out of here and it's going to change the state of this. And we know that air is going to come out of here and change the state of this. So what's happening over here is that if we take a look at this guy where we had a limit valve activates a relay valve. So A minus activates the relay valve. What's the other one that activates the relay valve? B plus. Oh, okay. So what's going on here is that B plus is activating and A minus is activating. So if I take a look at this, B plus is the last action in that group and A minus is the last action in the other group. So what's happening is that this A minus, as soon as this retracts, air is going to come out of here and it's going to go over here to this relay valve and it's going to activate this guy. As soon as it activates this guy, there's no more air coming out of here. So that means there's no more air coming out of this side. There's no more air coming into here and there's no more air going into there. And the air that we had going into A minus before, we've actually shut it off. We actually shut this air off. So remember, the air, that's the conflict. The air was coming out of the B minus. It was going in here and it was making A retract. So A is like, okay, I'm fully retracted. But this relay valve, this is the other half of the relay valve. It shuts off the air. There's no more air here. It's not there. the air is now coming out of here and it's making this happen. Now, I know that was a little confusing. Let's just continue on here. This is what's going on. We're going to consider this control statement, okay? So where's the conflict, okay? We know that the conflict is here. In this case, the last action is B plus, and we know that the next action after that is B minus, but as long as this is held, as long as this guy is active, he's telling this to happen. So this is held active, so therefore this can't happen. Okay, so action A is active but not held, and the limit valve is holding B plus. So what's going on is that this guy is being held, and this guy cannot happen. So it can't happen. So let's go on, and what we're going to do is we're going to take a look at the conflict. Now, just going back to here, we can see that there's an A and an A. So absolutely there's conflict here because there is no action between these at all. There are only 4 actions here, and the opposite actions, there's nothing in between them. So there's obviously conflict. So whenever you see 2 letters together, that's absolutely where you need to divide your groups. So this is how we define the groups. Essentially, each group has to have the same number of actions. Each group has the same number of letters, pardon me. Each group has to have the same number of letters. So what you're going to do is you're going to put this in between any point where there are 2 letters together. Absolutely, hands down, that's what you're going to do. And this is the group divider. And this group divider is dividing these 2 groups, group A, group B. Okay, so there you go. That's how you do that. So at any point, if there are 2 opposite actions. Now, the other thing is this. What's going on is that we have to find out what the group selector is. We've broken these up to 2 groups. And we saw before in here that what was going on was that if we were able to shut this air off, then there was no held action anymore. And the way we did it was we said, well, if the last action in the group here, limit valve A minus, if it can then go ahead and switch the relay, then we're going to turn that group off. Yeah. So essentially what's going on is if I go down here, the last action in the group turns the group off. It turns the next group on, and it turns the group off. So the group selector is the last action in the group. Okay, limit valve A plus and B plus are the group selectors. So this is the last action in this group. This is the last action in this group. This hits the pilot on the relay valve. It turns everything off here, and it turns everything on here. So this guy is also going to turn everything off here and turn everything on here. So if we can see, remember this guy, where the conflict was before? A minus is active. It's holding B plus. So therefore, B plus is held. And it would be nice if we could just kill the air from A plus. Therefore, there would be no air telling this to be extended, and the conflict would be gone. So the way we do that is as soon as this happens, it shuts everything off in this group and it turns everything on. So if it shuts everything off in this group, there's no more air coming in here and no more air doing this. So this guy is now active, but he's not held, in that this would be extended, but it's not held extended. So therefore, B can retract. Cool, eh? So now, this is how we get into defining the symbology and actually taking a look at what it looks like on the relay valve itself. So this symbol is essentially half of the relay valve. So this shows me what half of the relay valve looks like. This is the whole relay valve. This shows me this half of the relay valve, and this shows me this half of the relay valve. And take a look at it. So there's air going in here. This is the pilot activation. The air coming out is the air that's coming out of here. So this is the pilot activation, and this is the air coming out. And that air comes out, and it drives everything in the group. Watch this. So this is half of the relay. That's this half of the relay. So my last action is A minus. Okay, so as soon as this group finishes what it needs to do, A minus passes air, it flips the relay valve. There's now air coming out of here. There's no air coming out of here anymore, in that there's no air coming out of here anymore, because this is the other half. This guy represents this, and this represents this. This guy represents this half. So there's now air. As soon as this happens, what's going to happen here is that this relay valve is going to switch so that air comes out of here and it comes out of here. But there's no more air coming out of here, right? Because if I were to turn this pilot on, air would come out of here and it wouldn't come out of here. So what's happening is that the last action is called the group selector. Pretty cool. So now, all you have to do now is just understand the rules to do these sequential statements. If you don't understand why there's conflict, I don't care. I need you to know this. And some of that stuff, maybe you couldn't wrap your head around it as I went through it. Go back and watch the video again, and maybe you'll get that. But ultimately, you don't really need to know. What you need to know is how to solve it, how to design these sequential statements. You guys are experts already at designing sequential statements without conflict resolution. Now we're going to define sequential statements with conflict resolution, and we're going to see why they work. Okay, good. So here, this is my sequential statement with conflict resolution. All you have to do is put a slash in between here. Make sure you put air to the last action in every single group. The last action is the group selector. What it does is it shuts itself off, or it shuts its own group off, and it turns the next group on. So in this case, this is going to shut everything off here and turn everything on here. This is going to shut everything off here and turn everything on here. So when we shut these things off, we get rid of the conflict. Okay, so this is what it looks like, and this is how you define it, and this is how you draw it, and we'll take a look at what's going on here. And that's right. So when this guy activates, it activates this relay valve, it turns everything on here, and it shuts everything off here. And then by the end here, this guy shuts everything off here, and it turns everything on here. That's what's going on. Now, getting more into examples of all of this, we're talking about the last action in a group. Now, earlier, when I was up at that first slide where we're taking a look at defining how we can see control statements and how we define, how do we find conflict, the thing I was saying was that an action is defined as anything in a bracket. So the last action in this sequential statement is the whole group. So what's going on is that I need you to think about it this way. Remember, the last action in the group is the group selector, right? Here we go. It's the last action. The group selector always gets air directly from supply. Okay, what's the last action in this group? The whole action. So the whole action gets air from supply. What's going on is that we know this air has to go like this. We know it has to do that. And so because this is the last action, this air comes directly from supply, and it goes down here, up here, like this. So finally, like let's say A went really quickly, and it went, B went slowly, la-di-da-di-da, and C went out pretty quickly too. Now B is taking its time. You know what? There's still no air coming out of C+. Take a look at that. A goes out quickly. C goes out relatively quickly too, but A goes out really slowly. So A goes out, bam. C goes out, bam. B, la-di-da-di-da-di-da, finally gets there. Okay? So in that case, this relay valve is not going to be activated until all three of them get out. Yeah, and that's why we do this thing with all of the relay valves, so they all share air inside a bracket. Now, you guys get that. So we talked about that. Pardon me. We talked about that when we took sequential statements without conflict resolution. In this case, same thing. You're always going to have to do this. This is the last action in the group. So in this case, this is the last action in this group. Now, everything in the group, except for the group selector, gets its air directly from the relay valve. Everything in the group, except the group selector, gets its air from the relay valve. Okay, so let's take a look at this. What's the group selector in this action here? In this group, what's the group selector? Well, it's all of these. Remember, the group selectors are just limit valves. All of these limit valves are the group selector. Okay, that's fine. So they get air directly from supply. Does everything else in this group get air directly from the relay valve? Well, yeah, take a look at it. That's the relay valve. It's powering C, it's powering B+, and it's powering A+. So all of these actions get their air directly from the relay valve. Let's take a look at this guy. Remember, everything in the group gets its air from the relay valve except the group selector. Okay, this next group is these three actions. Does everything in this group get its air from the group selector except from the relay valve? Let's say that again. Does everything in this group get its air from the relay valve except the group selector? Well, yeah. Here's the group selector. It's the only thing that gets air directly from air supply. all of these things get air from the relay valve. This does, this does, this does, this does, this does. That's it. Now, you know how to draw all of these arrows. You guys are good with this. But the thing is, as opposed to each of these getting air directly from supply, they have to get air from the group selector. It's just like up here. See? This, as opposed to getting air from supply, it's getting it. So I said the group selector, I meant the relay valve. Just bear with me. Okay, this guy is getting air from the relay valve. This guy and this guy are both getting air from the relay valve. Everything in this group gets its air from the relay valve, except the group selector. Cool. So this is a cool example here where we're talking about a wheelchair lift that lifts up and then it does this. So it lifts up and then it does that and then it goes like this. So those actions happen to help someone get up out of a chair. So we can define a control statement there. What's happening here is that we can see that it starts, okay, so A minus and B minus are active. Whether they're held active or not, we'll talk about that later. But in this case, we know that at least A minus and B minus at the beginning, it starts down, are going to be active. Okay, so what's happening is that A and B have to extend at the same time. So they're going to go up at the same time. We're going to meter those so they actually go up and move at the same rate. They're not going to go, one's not going to go faster, one's not going to go slower. So, and we know how to meter. We talked about that in lecture. So you're going to meter those. Now, what's going on is that as soon as it goes up, then the next thing is that this is going to go down. So A minus is going to come down. So it's going to go up and then A minus is going to go down. And that'll help someone to get up out of the chair. So now the next thing that's going to happen is that the whole thing lowers. Now that happens when Buddy gets in the chair and he presses the button and then it's going to lower and then he'll be flat again. So this is pretty cool. We actually can put another push button in here. Yeah. But also we can see that there's conflict here. For sure there's conflict because we can see that these guys, there's a bracket around 2 of those letters. And we know that there are only 4 altogether. So it's more than a quarter. So here we go. We build our sequential statement with conflict resolution. And then this is really cool. Watch this, you love this. Dude, you can put push buttons in between actions. Yeah, you can put actually as many as you wanted in here. It'd be pretty cool. So I can actually put another push button in there as well. So we're going to put a push button here, but my point here is that the main push button, the push button that starts everything, always has to go before the first action. In this case, the first action is 2 actions. So the push button goes before those 2 first actions. And there you go. So that's all I have to say. And thank you very much for watching. And you guys know that you can just go over that again. The most important thing you can do is just practice sequential statements. Just do them over and over and over again and practice. And they get more complicated and there's some tricky things in there, but you'll get it. Go back to this video if you want. And all you have to do is follow the rules and you'll be golden. Okay, bye.